Okay, now let's move toward power transmission. We have discussed power generation, and once the electrical energy is generated, we need to transmit it or transport it till the end user. So, first step is to step up this power, because we cannot start this transmission process at low voltage. So, we normally use this power to transport it to the distribution end with the help of transmission lines, and the transmission networks are needed to connect generating plants to consumption points, and they create large power pools for increased reliability. Okay, then high voltage AC transmission, which is normally used for power transmission. It offers high transmission capacity per kilometer, lower line to voltage drop per kilometer, low transmission losses, reduced right-of-way requirement, lower capital and operating costs per megawatt transfer. So these are the main advantages of using high voltage AC transmission. It means when we are using the mode of AC voltage, and we are raising up the voltage with the help of transformer, step-up transformer, which is directly connected to the generating end. So you might be familiar that we call it a unit transformer that is connected to the generator to step up the voltage for transmission level. So by the help of that unit transformer, we convert this voltage, raise the voltage to transmission level, and high voltage AC transmission offers these different type of advantages. That's why we prefer it. And the equipment that we use in the power transmission is normally, obviously, first one is the transformer, which includes step-up transformers, voltage regulators, phase shifters, and step-down transformers. When we go towards the distribution end, definitely we will move from step-up to step-down transformers. Then apart from transformers, the other equipment involve transmission lines and cables, circuit breakers and disconnects, shunt and series reactors and capacitors, static wire compensators, and FACTS devices. I hope you might be familiar with most of these components or equipment. If not, then we will see them in. And if you're not familiar with the FACTS device, then it is flexible AC transmission system. Okay, then from transmission, next step is power distribution, because once we transmit generated power over long distance, then first we move from the distribution substation. At distribution substation, then we start the distribution part to distribute the electrical energy till the consumer end. So there is not a very fine line that defines the difference between the transmission and the distribution end, but it normally starts at a very low voltage. But the voltage levels, it normally differs from country to country. There is no specific voltage that is used as a standard worldwide to define the distribution voltage or the transmission voltage. So in normally power distribution, it receives electrical energy from the high voltage level at bulk power delivery points, and it supplies energy to consumers or the customers at standard voltage levels, and single phase and three phase, both type of consumers are obviously we have. Industrial consumers, they might need three phase voltage, and domestic consumers normally depending on the load, whether we have a single phase load or a three phase. So according to the requirement, the electrical energy is distributed from the distribution substation till the consumer end with the help of feeders and distributors. And the power distribution part, it is made up of the following main equipment. So main equipment is distribution transformer, which is involved in the distribution substation to step down the voltage till 11 kV till 220 or 440 volt. Then feeder sections, including the underground cables or the overhead lines. Feeders is the lines that directly start from the distribution substation, wires or lines starting from distribution substation till the consumer areas. Then we have switches, fuses, reclosers, all the protection equipment, and automatic load transfers, etc. So different type of protection equipment and feeder lines and transformer, this is the main component equipment which is involved in the power distribution. And you can see this is one kind of line diagram which is showing bulk power point here. which is we are considering it a transmission voltage that we obtain at the start of distribution point. Here this is almost 34.5 kV, and we have first step down transformer which is 34.5 to 15 kV. Obviously this is not a practical one line diagram for the Pakistan, our country. This is just generic, which may be for any country where the service voltage and things vary. In our country we might place it like 11 kV. 11 kV industrial customers will be supplied here, and if there are no industrial customers, then for commercial or residential customers we will have to step it down further, like it's 5 kV. Some commercial customers might need 5 kV in any country, and then we have residential customers. It's 208 like here, but we have 220 to 30 volt requirement in our country. So there are different types of distribution part is mentioned here, which is step down. These are 2 to 3 step down transformers are involved. These are the feeder lines, and then even then this is not a very simple network. It involves a lot of connections and equipment which is not mentioned here, which is covered in the power distribution part. So this is all about the electrical power system components, and what are the main targets when we talk about the power balance. Main operational goals involve power balance, which means generation must remain balanced with the demand. So which means total generation is equal to total demand. If this thing is finalized, I mean if it is fulfilled, then there is no shortfall of power generation. There is no outcome which we see in the face in the form of load shedding. And second important goal is system security. Equipment power flows must not exceed the equipment ratings under normal or a single outage condition. System security is a big concern in electrical power system, because when we talk about the power flow, input power, output power, the power flow should remain within limit. Power flow should not exceed the equipment rating, because it can highly affect the equipment. If excess of power is transferred, the equipment might damage. Then power quality consideration. In case of when we talk about the power quality, we talk about the frequency regulation and voltage regulation. What we require in terms of frequency regulation is the system frequency must remain within its operational range, and the operational range is as we have 50 to 60 hertz. So in case we have 60 hertz standard, then it's like frequency should remain in 59.5 to 60.5 hertz, or 49.5 to 50.5 hertz. If it is the 50 is the standard. So in the voltage regulation part means bus voltages must remain within their operational limits. There is certain limit on the voltage and on the frequency both. So whatever is the limit set, all the overall whole bus or the whole electric system must follow this regulation. And the other thing is the purity of sine wave and continuity of supply. These are the two main concerns that should be considered while following the power quality of the power system. Then power system organization, which mainly includes it is basically the utility or the consumer power authorities have how this system is organized, how it is managed. Power utility structures involve, there is a traditional structured and there is a restructured or deregulated part. So we will see both. In the traditional utilities, what we have seen in the previous years is normally the traditional utilities, they operate as monopolies. They have captive customers. They have been regulated by the government. They have to get regulators' approval for rate increases, and normally they have little room to increase the generation efficiency and have largely moved toward the vertically integrated business structures for improved profitability. So there are a lot of concerns in the traditional utility system. And when we talk about the regulated power supply, it means we need to talk about this virtually integrated business structure, which involves in transmission and distribution network. We talk about the production inputs, production, transportation, distribution. Everything should be individually tackled and individually taken care of. And in regulated, basically in deregulated structure, we have necessitated the breakup of traditional utility structures into independent business units. Generation should be independent, transmission should be independent, distribution should be independent, so that they have more authority and there a more chance of growth. Normally we have Gencos, which are the generation companies, power marketers. We have Transco, which is transmission company as an owner, then independent system operator operating the transmission network, retail service providers, and distribution companies as are on the different level. So this is the deregulation industry structure, which is you can see as the industry of the future, in which every area will be independent. Generation system will be deal separately. It is not like whole system is dealt by some government and there is only one authority, and no change in the transmission distribution system can be done without any approval. So this is a separate area. Transmission network is a separate area, distribution is a separate area, and customer is already independent. So this is the kind of structure which has been legislated by the government, hoping that it results in increased competition, reduced rates, new technology utilization in generation, transmission, and distribution, influx of private capital, or increased outside investment in power system infrastructure. So the restructuring and deregulation is the working environment for the new millennium power system. This is just hope that we will move to the future power system, and like we will moving toward the smart grid environment, in which the main target is to make everything independent, including the customer, including the generation and transmission in every aspect of the power system, so that we may have the authority to see a lot of improvement in the power system. But the challenging task for the new environment is quick decision making that we have to follow. So this is all about the basic overview of the electrical power system, and in the next lecture, inshallah, we will start with the discussion of per unit system of calculation, which is the very first topic from technical point of view that we're going to follow in the next lecture. I'll see you in the next lecture. Till then, Allah Hafiz.